Today, we will talk about independent events, but now we will be using a two-way frequency table. So the main idea here is that we are going to assume that we have two events, event A and event B. Now, we will claim that A and B are independent if this is true. If the probability for A is equal to the probability of A given B, where P of A, this is just notation to indicate the probability of A. So P of A is explained here, which is the probability for the event of A, and PA conditional B, we can express it in this form, PA slash B. Now we will talk about more about conditional probability. This is what we can claim as a conditional probability. We will talk about more about conditional probability in future lessons, but right now we're just going to be using a two-way frequency table. And again, if we want to show that A and B are independent, all we got to show is that this is true. So keep that in mind. So let's see. And again, remember that if we want to show that A and B are independent, all we got to show is that the probability of A is equal to the probability of A given B. Now, how can we find the probability for each one of them? Well, let's look at this example here. It says the table shows the genders and music preference in a group of people. Okay. So we know that A represents those who prefer rock, and we know that B are those who are males. So now the question is A and B are independent? If you prefer rock, is that independent from you to be a male? Well, let's figure out if that is true. And again, all we gotta show is this. The probability of A equals the probability of A given B. So let's talk about a P of A, which is the probability of A. But know that A are those who prefer rock. So if you want to find out the probability of those who prefer rock, well, first we need to figure out how many of them prefer rock. So prefer rock, we have a total of 36. There are 36 individuals who prefer rock, and there's a total of 45 individuals who get to be in this two-way frequency table. So if we want to know the probability of that, we can see that 36 divided by 45, this is 0.8, which, if we want to know the percentage of it, we multiply by 100, and this is 80%. Okay, so know that the probability of A, we can use it this way. So now to find out the probability of A given B, let's see what this means. This means what is the probability of those students or those individuals, let's call it the group of people, what is the probability for those people to prefer rock given that they are male? Well, let's see in this table. Here, A represents those who prefer rock. This is the column for rock. But now, we want to know, out of all this, those who prefer rock, how many of them are also male? Well, prefer rock and male, that's 12. So we have 12 divided by how many males are there in total? Well, males, so that's 15. So this is how you find the probability of A given B. First, we're looking at all of them which are male, and then we concentrate on those who prefer rock. So on the top, you can think about it as the combination of both of them. Those who prefer rock and are male, and on the bottom are those who are just males. Well, let's see what this is. 12 divided by 15. So this is 0.8, which it translates to 80%. So notice that P of A is equal to 80%. P of A given B is 80%. So that means that P of A is equal to PA given B. So this is an example of independent events. So we can claim that A and B are independent, which is our final answer. Oops. All right, perfect. Let's take a look into another example here. So we have this. It says there are 155 students, which are shown in the table below. Now, let's see what this means. It says for this group of students, thus this data suggests that gender and preferred music styles are independent of each other. Well, in here, they're not telling you what A and B are. So let's see what they are. A. Okay, so I actually changed the problem a little bit for it to make a little bit more sense. But here's the question. We're still going to use the same table. It says for this group of students, the data suggests that the female gender and the techno music styles are they independent from each other? Well, let's say that A are the female gender, and let's say that B are the techno music. Now the question is, are females and techno music independent from each other? Well, let's see. If we want to know if they're independent from each other, we gotta know P of A is equal to P of A given B. So this is what we need to show. Well, let's find the probability for each one of them then. Let me just move this to the side because remember, this is what we want to show. Let me just put it in the box so you know that this is our objective. So let's actually figure out what they are. So P of A, where A is the females, well, let's see, how many females are they in total? Well, there is a total of 79 females, and there's a total of 155 in the survey. So what is the probability for you to be choosing a female? That would be 79 divided by 155. There's an extra 5 there. Let me delete that, so that's 155. So we're going to have 0.50, 96. Let's multiply that by 100. So there is a 50.96% probability for us to be choosing a female. So now let's figure out what is P of A given B. Well, we're looking for those females who like techno, which females who like techno are 54. And we need to divide it by the total amount of females, which is 79. We find this out, 54 divided by 79. Let's multiply that by 100. So we have a total of 68.35%. So notice the following here. We can see that P of A is not equal to P of A given B. Because this is not true, then A is not independent. Let me write that a little bit clearer. It's not independent to B. So they're not independent events. And because they're not independent, we can claim that they are dependent. So now, here's your entrance ticket. Given the following table, identify if the student is a male and the student preference reality series are independent of each other.